Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Object-based image classification. That is what we're busy with using the OTB plugin within QGIS. It's a little bit different than our normal, I wouldn't say normal, but our generally accepted image classification methods and techniques, which use image or use the spectral signatures of the locations. In this case, our first step is image segmentation. As that we only do that with object-based because it's about not just the spectral signatures of the of our locations or our pixels, but also the textures and the shapes and all of these sort of things. Okay, so we've done that in 202, so please go and have a look. I'm not going to go through it. Please, before I continue, like, subscribe, share the video. Let's go to those numbers up, and also you're more than welcome to join me on Facebook. We can have a chat on there as well. So please make use of my social media. Let's get the numbers up. I really appreciate your support. It means a lot. So yeah, please, 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 please hit those buttons. Okay, so back to the video. Remember we did the image segmentation using the OTB plugin, which is on your right hand side. There is the segmentation, and we use the segmentation tool within the OTB plugin. There's a couple of parameters that we can manipulate, can change, that should theoretically make a difference, but they don't very much make a huge difference. So there's and how many segments? Let's have a look there. If we go right click and we go object attribute, there was 1,734 segments. So it took my region of interest and it created 1,734 segments. We can lay the segments over. You'll see it sort of puts things that fits. It basically puts in the same segments. See, there's some missing ones there. You'll see there. This one is quite good. It captures that. So visually, you'll have to compare it now, in terms of the number of segments. If we, for example, do this, remember this one here, we did this one here. Let's have a look and see what this looks like. So you'll have to visually inspect to make sure you're happy with the segmentation process. But for now, let's agree or let's assume this is the best option. Okay. Again, we can always come back at the end when we've done the classification. We can always come back and change the segmentations, rerun it, but that's totally up to the user. Okay, so once we've done this step, okay, so remember segmentation is step 1. Using the OTB plugin. Now what we need to do is we need to do zonal statistics, meaning we need to capture the band statistics for each of these segments. Remember we are using our, where is it now, our stack raster, and within our stack raster we have, if you go to properties, we have bands 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12 bands. So what we want to do is for each of the segments, create the statistics of these different bands. Okay, so for each, because if you see each segment, if you open this now, each segment is empty. There's no information for each of these segments. So what we want to say is for segment 1, what is band 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 statistics? What is the statistics? The band statistics, band 1 to 12 for segment 1, for segment 2, segment 3, segment 4, and so forth, and so forth. So we want the band statistics for each of these segments. You can have a look there. Now the segmentation based on the true color actually looks quite good. It doesn't look too bad. Okay, so let's, as I said, we assume this is the optimum segmentation. Okay, so the next one within the OTB, we're going to go zonal statistics, and we're not going to use the normal RGDOL raster zonal statistics. We want to use the OTB because these ones do them individually. So you have to do zonal statistics for band 1. Then you have to do it for band 2. Then you have to be it for, if you use the OTB, you can do all of them in one time. You don't have to do them separately. So we left click on zonal statistic. We say, what is our image? That's our stack raster. Remember, that's the one that we work with, and that's the one that we've created the segments on. Background, we can do that. Vector, yes. Mean shift, input data. So the mean shift is our segments, which is this one that we're using. Let's make sure, yes, it's that one that we're using. Vector output, float, and we're just going to give it a name. So it will basically take all the bands within this image and generate the relevant statistics for each of the segments. And let's save it and say it is segmentation zonal statistics. Okay, we don't have to worry about it. It's already included there. Segmentation zonal statistics. Click save and let's run it. It may or might not take time depending on the number of segments you've got. In this case, it was quite quick, so let's close it. Let's open it. There's the zonal statistics. Let's open it. Open attribute table. And there we go. So in zone 1, there's 318 pixels. The mean of band 1, of band 0 is 0.39. Standard deviation of band 0 in that segment is that minimum maximum. Mean for band 1, standard deviation, minimum maximum for band 1. The mean for band 2, the standard deviation, etc., etc., up to maximum, band 11. So 9, 10, there they all are. So I've created the band statistics for each of these segments. What segment has the most? There's 101, so that's the least. Yeah, segment 1675 has got 189,450 pixels. Let's see if we can find out where is that band. Oh, where's that one? Oh, it's this one here. We can actually delete that one. Let's go ahead and delete it. Let's see what is this one here and that one there. Let's see. No, yeah, these are all these ones there that we actually don't want. Doesn't matter. Come on. Yeah, we can. What shall we do? Shall we delete them? It's not going to make a big difference because it's not going to make any. It's not relevant to any of the things that we're going to do. So what we can, let's delete it. For features, there we go. Let's delete it because it's not relevant to what we're going to do. So let's save it, and there we go. So it's 173 for features. Let's look at where is segment 1. There's segment 1. Let's open it a bit. So that's segment 1. So basically it says that that segment has 318 pixels. The mean pixel value for band 1 is 0.039. Standard deviation, minimum, maximum, mean pixel value for band 1, 0.04, etc., etc. Let's see where's band 2 should be then. Segment 2, you can see it's smaller than segment 1. There we go. Okay. And we can close this. I want to, Okay, so we've done the zonal statistics. Let me just unselect, properties open, and we're gonna go um, unselect. I want to unselect. Okay, there we go. Okay, so there is my zonal statistics data set. So I hope you understand what we've done is we've created the statistics for each. Now what we want to do is remember we have our training. There they are. Okay. Um, let's use the training. I'm not going to use the assessment. Let's use the training. Okay. So remember the training consists of, let's go open attribute. The training consists of 1, 2, 3, 4, 5, 6, 6 polygons that is classified as water. 1, 2, 3, 4, 5, 6, 7 polygons that's classified as veld. 3 that's classified as mount, 4 that's classified as mountain, etc., etc. So what we want to do is we want to generate the statistics for these um, classes. Okay, and there they are. So see that one is there. Okay, so that one is there. Where's the other ones? Let's have a look and see. So farming is green. There's our farming. Mountain, there's our mountain. Urban is red. Let's have a look and see if it sits. So it sits within that one. So it will have the same ones, same zonal statistics, etc. Okay. So the next one is what we want to do is want to generate the zonal statistics that we've got, and we want to generate it for each of these um, training polygons, these sample polygons that we're going to use to do the classification. So what we're going to do is we're going to go join attributes, attributes by location, location. So, but I don't want to, I want to join. Let's see. I want to see if it's in the OTB, but it doesn't say OTB. Is there nothing in the OTB that we can use? I prefer to work in OTB, but if there's nothing, um, let's see where zonal statistic is. Oh no, it's image manipulation. So let's quickly go back. Um, let's try image manipulation. Let's see if there's zonal statistics, but there's no join. I was hoping there would be a join, but there's no join. Okay, so that's fine. Join attributes by location. Okay, so that's what we want to do. So um, what we want to do is to use the segmentation that we've done now, the zonal statistics one. Where is it now? This is the segmentation zonal statistics, because remember, all our data sits now in this one, okay? And intersect, and we're going to compare it with our training. That's right. We're going to say it's 1 to 1. We're going to discard um, records, so that's fine. What else? Intersect, that's fine. Segmentation, join attributes of first matching feature, only 1 on 1. And that's it. So let's quickly save that. And we're going to save that as segmentation, zonal, um, sorry, yeah, zonal statistics joint training, long names. Okay, so let's do that, and we're going to say save. Okay, and we're going to run. No index. Okay, so performance will be severely drained. And okay, let's have a look and say. So why did it say joint training? Let's open attributes. And we should have something here at the back. Nope. It doesn't want to. Why? Okay, so it's a joint layer. Let's say open attribute. Let's see, should be something. Here we go. So this is what we're looking for, is the ID and the class. So it has identified all the segments that relates to our training samples. How many is there? 117 of it. So this segment, that one there, contains a water training sample. Let's have a look. Close. Let's quickly close that one there. You see there it sits. Um, segmentation zonal statistics. Okay. And Sentinel. Okay, so let's quickly go. See there it sits. There's the river. If I go training, and you see there's the river, the blue, the river there. So therefore, it took that, identified that segment as river. See, it identified that segment as river. So let's take another one, felt. So it would have identified this specific segment and 199, it would have identified that it's felt. Let's go and have a look and see. Where does it sit? Felt. But why is it not showing? Let's delete this. Yeah, let's keep it. It's fine. There we go. There it sits. It's identified that as felt. Let's have a look and see. Yes, you see, there it's felt. So felt, which is this color here, you can see that. So it would identify all these segments as felt. So that would be labeled as felt. Let's have a look and see that segment. See that segment runs through there. Let's have a look and see what it is. Yeah, that's part there. That's the felt part there. Let's have a look and see. Joint layer. So it's this part here, which is felt. You can see this is felt. Yeah, this is not agriculture. This is felt. Okay, so you see that. So it touches that part there. So it's this part here. So that's cool. Joint layer. So let's quickly have a look and see for the farming urban. Let's have a look at urban. This one here. So this is segment 1454 that it is identified as urban. I'm going to try something now. Let's quickly just first have a look. See where is this one? There it sits. There it sits. So it, joint layer. So it touches this one there. That's the little part that it touches. You see, it's not very good. See, it touches that part there, just that part there. Now it makes this whole thing urban, where this whole part is not urban. So this is clearly an indication of wrong. Um, it's pretty wrong sampling. So yeah, see, it's the joint layer. You can see there that obviously is not going to be urban. But it's clearly an indication of our sample being not optimal and then our segmentation not being correct. But let's not despair. But it does give you some indication of where we made mistakes. So let's do the next one. Where's this one? Let's take it this one, see what this one looks like. Where's that one there? There we go. So again, similar. This is urban, that one there, for sure. Okay, so this is better. So this whole part is urban. If I take this out, yeah, this whole part is urban. So in this case, it's not bad. Okay, let's be honest. In this one, it actually works pretty much fine. This whole part is urban. The segmentation is maybe not the best because that part there shouldn't be there. It's only this part here, but it's not too bad at all. Could be better, could be worse, like the previous one could be worse. Okay, so that's good. So what we've done now is we've got all our segments. See, there's all our segments that sits within our or is related to our training samples. And we can do it for our assessment samples as well. So let me just save this because it was supposed to save as this one, but obviously it didn't. So I'm just going to say rename. I'm going to copy this. Then I'm going to delete this one, remove it. And I'm going to take this joint layer and I'm going to export it. And I'm going to go with my image classifications. And I'm going to go there. Now it already exists, so I'm going to just segmentation zonal statistic. I'm just going to take that S out, save it. And then I take this out because it's a temporary layer and there it sits. So I potentially can do the same for the assessment ones. Just to run the two to see which one is better. So you can do that. Obviously, the more training samples or samples you have, the more that you can do on this one. Um, but anyway, let's just park do. Okay, remember to save. Okay, so what we've done now, just to recap, we've done the zonal statistics, and then from the zonal statistics, the data, we then isolated the segments that is related to our training samples with its associated zonal statistics. So what I want to do just quickly to see, let's go back here. Um, this one here, open attribute. Okay, so let's quickly have a look and see. There's a lot of statistics here. But ideally, if I go, for example, the mean. Let's go. See, the 11. Then obviously, there's sand. You don't want sand to be somewhere. You want them to be grouped because that means the spectral signatures are the same. You see, there's a mountain there that actually should be felt according to band 11 and not mountain. Let's look at urban. You see this one there? There's that mountain. So there's some confusion here. So farming, water seems fine. Farming in the main seems fine. But there's some urban. So what we could, you don't want to. Okay, so let's go to band 1. Band 2, which is mean of band 2. Okay, so let's have a look. Because band 2 is a virtual, it's true colors. Let's have a look and see. Go sand. Yep, sand is fine. Veld, urban, veld, urban, 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 veld, urban, 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 veld. Let's go to the bottom. Mountain seems fine. There's some issues. Where's water? There's water there. There's water there. So there seems to be some overlap again. Hope you get the understanding of what we would like to see happening. We would like to have all these things grouped. So there's farming. Okay, so there's farming group. Nice. There's one urban that's outstanding. There's farming. Um, Sand. So sand and farming to the most degree. It's veld and urban and mountain. So if we go here, so farming and sand. Um, Water, interesting. I would have thought water would be very. I can see the veld and the urban and the mountain. I could see those three being a little bit more tricky, but water, I would have thought that water would be clear cut. Anyway, what we could do is, for interest sake, I'm playing around now. Okay, I'm playing around now. Let's quickly do the following. What I'm going to do is I'm going to take this and I'm going to export it as a CSV file. And then we're just going to go export comma separated file. Let's go, and then we're going to go segmentation zonal training. I'm going quick now. I'm not going to worry about the spelling now. Let's save. Okay, I'm just going to delete it from, remove it from there. Then I'm going to go into that folder, image classification, open it. Now let's quickly put the signal, create a graph of the spectral signatures. So we're going to go data, we're going to text to columns. Next, we're going to go comma, we're going to go face. Let's quick, what I'm going to do now is I'm going to say insert, we're going to go pivot. Okay, so we're going to go mean. And I'm going to go class. I'm going to count down on a count. I'm going to go average. Why is it okay? Because it's in points. So I first have to go find. And I'm going to find points and I'm going to replace it. Commas, replace all. Take a bit of a time. Done, close. And we're going to go, where is it now? Pivot, and we're going to go, nope, where is it? Insert, why? Pivot chart, and we're going to go refresh. There we go. So the mean, so you can see farming is there and sand is there. You can see water, veld, urban, you can see between mountain. So you can see these three are fairly similar. Let's do mean to average. You can see in this case farming and mountain is very similar. And these ones are, you know. Anyway, we can play around with these numbers, but it gives you an understanding. So ideally, what we want is we want all of these things to be, you know, as unique as possible. So we want the farming statistics to be unique, the mountain to be unique, no overlaps, because you know it. Then the classification is just so much more accurate. Let's have a look at 3. Average. You can see the spectral signature for sand, especially for 3, is much higher. You can see for farming. You see urban and veld, yeah, and water. Interesting that water is so close. I would have thought, yeah. Yeah, it could be, this could be the result of the segmentation that's not properly done, etc. So sand is always standing wide. And so you can continue. But anyway, I'll save that for another video and stuff. We can have a look at that for another video. So what I want to do now, and then please remember to save. Okay, so now we've done our groundwork, we've done our homework, and we can now take it to the actual object-based image classification itself. Okay, so these are necessary steps that we have to do to get to the classification. So what we're going to go, once we've done this, we're going to go back to our object-based, and we're going to go to where we're going to go to the actual um, classification within the OTBs. But that we'll get to, so intersect this. By the way, remember in my first video I said this, the large scale segmentation, large scale is doing the 2 steps that we've done now. It does all these, the 3 steps that we've done up to now, i.e., well, not the last step, the join, but the segmentation and the zonal statistics. It does that in one. Whereas if we use segmentation, we do the segmentation and then the zonal statistics. When we do large scale mean shift, it combines those two steps, but then still we have to do the zonal statistics. So it's either step number 3 or step number 2, depending whether you use segmentation or large scale. So now we've got all of this in place. Now we could go and we can now go into our learning where we're going to do, you see there's k-means classifications, there's your train vector classifier, train vector regressor, vector classifier. So next step will be the train vector classifier. That's what we're going to do. You'll see there's our input, etc., etc. So that's all in the next video that we're going to do. But for now, what is this fusion of classification? Sorry, I get easily distracted. I don't know exactly what that is, but it looks interesting. Anyway, get easily distracted. So this is now my second video in object-based classification, which deals with steps 2 and steps 3. Or in my case, steps 2 and 3, where the first video just dealt with the image classification. This step video deals with the joint attribute, zonal statistics, and the joint attributes by location. So this is ultimately, so we've got 3 images or 3 files now. We've got the zonal statistics, the training one, and the training one, and then obviously the stack raster. So that's the 3 files that we're going to work with now. Is our original image, our zonal statistics for all of the segments, and then the zonal statistics for those segments that's related to our training samples. Okay, so I hope you're still following. If there's anything, just give it a comment and then I'll respond to that. But for now, I think let's park there and make ready for the next video. So with that said, again, please go and like and subscribe, share the video, watch the video. Please watch the videos. Let it run, even if it runs there in the background. It counts. So any help and support you guys can do, I'll really appreciate it. So with that said, I'll see you on the other side.